Kurtz here for Easy Access Math, and today we have a video on number sequences. Number sequences will not be on the Math M2 exit exam, the Maple TA exam, but may show up in such courses like Math 7 or Math 4 at Kingsborough Community College, and similar courses at other CUNY schools. So stay with us and learn a little bit about number sequences. Hi, Kurtz here, and this is another Easy Access Math video. Today, we have a lesson on sequences, or pattern recognition. Sequences are all about recognizing a pattern, and they come in different varieties like arithmetic, geometric, squares. Stay with us. We'll be right back to discuss some sequences and some methods of working with them. Okay, we're back, and I want to talk about some number sequences. For one, we have the arithmetic sequence. Take a look at the first three numbers, 3, 9, 15. In the arithmetic sequence, we are adding the same number every time, and that's called the difference. Over here, can you see the difference? Well, of course you can. It's 6. 3 plus 6 is 9, plus 6 is 15. And I'll complete the next few numbers in the sequence. 15 plus 6 is 21. 21 plus 6 is 27. And add 6 more to 27, and we have 33. Next, we start with the same three numbers, but the sequence is geometric. In the geometric sequence, we multiply. That's called the ratio. Now, it may also be division if the ratio is less than 1. In this case, it's multiplication. 3 times what is 9? When numbers are right next to each other, you could see what the difference in arithmetic and ratios are. Sometimes they're not, and you would have to work it backwards. But here, we could see that the multiplier, the ratio, is 3. 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And you keep on multiplying by 3 for that sequence. Here we have the sequence of squares, right here in green. These are your perfect square numbers, and it's a set sequence. 1, 4, 9. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So you could recognize the sequence of square numbers. Cube numbers, it's the number times itself, and again times that same number. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And 6 times 6 times 6 is 216. And so on, it continues. Triangular numbers are quite interesting. In the triangular sequence, you're adding one more number to each space than you did before. And it's called triangular because they actually make a triangle. Notice the first number here is 1. Then we add 2 to that 1, and I have 3. If I add 3 to the 3, I end up with 6. Kind of make a bowling pin design or a triangle. And if I add 1 more than the 3, now I'm going to add 4, I have 10. To this, add that to the 6. Now I'm going to add 5. I'm always going up 1 more to the 10, and I have 15. And I'm going to add one more than that 5 to the next one. I'm going to add 6 to the 15, and I have 21. And that's your triangular numbers. Now, this is a mystery sequence, and if you're a New Yorker, you might recognize these numbers. Remember, sequences are all about number recognition and pattern recognition. They're not always mathematical. Keep that in mind. See if you recognize this sequence: 4, 14, 34, 42. And see if you could determine what the next two numbers are. You know what? I'll give you the next number. Think about it. I'll put it down. It's 59. See if that gives it away. We'll be back with the answer to this sequence and more mathematical sequences right after this pause. So stay with us on Easy Access Math. All right, we're back. Did you figure out our mystery sequence? I'll give you the next number. It may surprise you. It's 125. Remember, I said if you're a New Yorker, you may recognize these numbers. Not mathematical. I know some of you may have been trying different adding or multiplying, but this sequence is the sequence of A-train stops. It's the stops in Manhattan on the Express A train. And it just shows you that a sequence could be just about anything. We'll be back to talk about the Fibonacci sequence right after this brief pause. Welcome back. Before our break, I told you we were going to talk about the Fibonacci sequence. The Fibonacci sequence, or the Fibonacci numbers, this was a sequence created by Welcome back. Before the break, I told you we were going to talk about the Fibonacci sequence, or Fibonacci numbers. The Fibonacci sequence was created by Fibonacci, also known as Leonardo of Pisa, of the Leaning Tower fame. He lived between the years 1170 and 1240, so this sequence has been around for quite a while. Take a look. It starts 1, 1, 2, 3, 5. And do you see a pattern? The pattern of this sequence forms its rule, and once you know it, you could carry the sequence on forever. If you notice, each time the last two numbers in the sequence, like 1 and 1, get me the next number. So 1 plus 1 is 2. If I add up the next two numbers, the 1 and the 2, I get the next number, 3. 2 and 3, well, that adds up to give me 5. So what do you think the next number in the sequence will be? Well, if you add up the last two numbers, the 3 and the 5, you get the next number, 8. And then if you continue, add up the 5 and the 8, you get 13. And if you add up the 8 and the 13, you get 21. And that keeps going and going that way. Now let's say you don't have consecutive numbers, but you know it's the Fibonacci sequence. Here I have 55 blank, 144 blank, and 377. What I need to do, since I know the 55 and this number missing add up to 144, I need to subtract, do the opposite, work it backwards. 144 take away 55 would give me that middle number, and that middle number is 89. 144 take away 55 is 89. Once I figure that out, then I can just add the next two, and that will give me the 233. You also could have figured this one out by subtracting the 144 from the 377. You would have ended up with the 233. So that's a way to figure it out if you don't have consecutive numbers, and you have gaps between. That's the Fibonacci sequence. When we come back, we're going to do some math work with some sequence, see how you can figure out some really large terms in the sequence and sum those terms. So don't go away. We'll be right back with more number sequences on easy access math. Welcome back. Our last lesson on sequences today is finding the nth term of a sequence and then finding the sum of those terms. And so, to practice, we're going to start with this sequence, 7, 13, 19, and it keeps going. And do you see the difference? The difference, of course, is 6. 7 plus 6 is 13. 13 plus 6 is 9. 6 is the difference, and it would keep going. Let's practice with, let's say, looking for the first 8 terms, the 8th term of the sequence, and then let's get the sum of the first 8 terms. Well, of course, I could do that easily by just carrying out the sequence. If I want 8 terms, I just go 19 plus 6 is 25 plus 6, which we know is the difference, is 31. Plus 6 is 37. Plus 6, 43. Plus 6 more, 49. Just keep on adding 6 each time. And so I know that my 1, 2, 3, 4, 5, 6, 7, 8th term is 49. And if I wanted to get the sum of those terms, I would just have to add up all of these numbers. Not too many, so I could probably do that in a short period of time. But we do have formulas if we need to find higher terms and sums of that sequence. So let me introduce you to the 2 formulas in question. To find the term, for example, the 8th term, the formula would be T1 plus n minus 1 times D. And I have a handy legend over here. T1 is the first term. Now, in orange, I put an alternate. You could use F for first term. Same sequence, just different letters, whatever helps you remember them better. And Tn, when we get to the sum sequence, is the term you're looking for in this case. It's the answer to the term formula, 49. You could also call that L, or last term. Now remember, it's only the last term that you're looking for. Sequences keep going and going and going forever. But to make it short, and remember you could call it the last term, or Tn, which is the number position you're looking for. D is the difference, and in this case the difference we see is 6. And n by itself, not Tn, not n all by itself, is the term position you're looking for. In this case, I said I want the 8th position, so n would be 8. 1, 2, 3, 4, 5, 6, 7, 8. The 8th position. So n is 8. Now, to get the term, all you need to do is plug in the numbers into this formula. Remember, I said you could use F instead of T1 for first term. And when we get down here, you could use L, if that helps you remember the last term, which is Tn, the same thing. And I'm just going to now plug in the numbers. My first term is 7. And 8, take away 1. In the parentheses, because I said n is, I wanted the 8th term, times the difference, which is 6. And now I work that out using our order of operations, PEMDAS. And we have a good video on that you can check out, which gives me 7 for parentheses first. 7 times 6 is 42. Times the 7 on the, adding the 7 on the outside actually, I have to put my plus signs in. So I'm adding the 7 on the outside. 7 plus 42 gives me 49. Always remember to carry down your formulas. Make sure you have all your signs in check. There's my plus signs. And so that was 7 plus 42. 49. And you see, 49 was our answer. Now let's say I want the sum of the first 8 terms. I want to add up 7, 13, 19, 25, 31, 37, 43, and 49. I want to add all of those numbers up. Here's how you do that. What you do is you plug it into this formula, which is n, and in parentheses, t1 plus tn, which is the first term plus the last term, the term that you were looking for. That was the answer to your first formula when you wanted to find the 8th term. And you could also call it F plus L, first and last. These are the same thing. So I'm going to substitute. N is still 8, the term position I was looking for. T1 is the first term, which is 7, plus, make sure I have my signs correctly, the last term, which was 49, and it's always over 2. Do my parentheses first, order of operations. 7 plus 49 is 56. Have the 8 on the outside, over 2. And, you know, if you feel comfortable, you can cancel the 8 into the 2 and have 4 times 56, which would give me a total of 224. Now, if you added up all those numbers, you could try it, you will get 224. We'll be back in a minute because I want you to try, let's see, the 100th term of this sequence. Now, of course, we figured out pretty easy the 8th term. We just had to carry it out. So this, doing the formula is kind of like a check. But it would be a little cumbersome to write 100 terms down or 1,000 terms and then have to add all of those up. The first term plus the second term. So that's where these formulas come in handy. So let's try them with the 100th term. We'll get the 100th term and then the sum of the first 100 terms of this sequence. And we'll be back to work those out. So stay with us on Easy Access Math. Okay, I hope you were able to work out this problem and get the 100th term and the sum of the first 100 terms. Now let's do it together. Let's see how we did. Remember, the formulas for the term, t plus n minus 1 times d, the difference, and to find the sum n, and in parentheses, t1 plus tn, the first and the last, over 2. Now, we can't get the sum before finding the last term, the 100th term. We need to do that first. So we will do the term formula for the 100th term. Now, it would be very cumbersome writing down 100 terms. You'd be going forever. So this is where the formulas come in really handy. So we have the first term, it's still 7. 7 plus, don't forget the plus sign. And we have the n minus 1, which is 100 minus 1, because n, the term position we're looking for now, is 100, times the difference, which is still 6 apart. And now we will work that out, order of operations. 100 minus 1 is 99. 7 plus 99 times 6, order of operations, we multiply first and we get 594 plus the 7 gives us a total 601, and that is our 100th term. B100 equals 601. We would be there all day if we actually wrote out 100 terms. And let's say we needed 1,000 terms. That's why we have the formula. Now, to get the sum, we will take the 100 term. That will be our Tn, our last term, and all the other symbols remain the same. Our n is still 100, and we make our parentheses, and we have the first term, which is 7. The last term, the Tn, the 100 term, 601, and we will divide that by 2. And that gives us, when I multiply that, 608, do my parentheses first, of course, and then multiply, which will give me 60,800. You could also cross cancel. Divided by 2, and that gives me an answer of 30,400. So the sum of the first 100 terms, when I add up 7 plus 13 plus 19 all the way to 601, would be 30,400. But it was easy with the formula. I hope you enjoyed our lesson on sequences, and I hope you check out our other videos at Easy Access Math on Facebook and YouTube. Remember, Easy Access Math, we try to make math a little easier for you. So check us out, and thank you for watching.